Today we will explain Tesla's motor strategy one at a time. You may have read a lot of information. Some say that Tesla started out with induction motors very aggressively. Then they switched to permanent magnets. I saw the induction motor come back recently. It's like I keep hitting myself in the face. But that's not the case. You just spread out the timeline. And what you see is that Tesla's logic is pretty consistent from beginning to end. And there is a clear reason for each replacement. So let's start with the timeline. The first paragraph is from 2012 to 2016. Early Model S and Model X all used induction motors. The reason is very simple. Rare earth prices were high at that time. Permanent magnet motors are not cost-effective. Plus, the induction motor matures. Durability does not rely on magnets. As long as you give electricity, you can run. Ideal for the era of electric vehicles where the early market was still unstable. But induction motors have two fatal flaws. First, it's inefficient, especially when cruising at high speed. The power consumption will be much more than that of permanent magnets. Second, the heat loss is relatively large. The output will become more and more difficult for a long time. Then enter the second phase, 2017. This year, the Model 3 was launched. The motor was officially changed from induction to IPM, permanent magnet motor. This is the first major blood change. Model 3 is going to be sold in large quantities. Battery life and efficiency are of paramount importance. Permanent magnet motors are particularly efficient at medium and high speeds. IPM, also known as embedded permanent magnet, combined permanent magnet torque, and magnet or resistive torque. Low speed saves power, and high speed can maintain output. Thermal management is also easier. It can be said to be the most suitable motor for the main model. The third stage is 2019. Model S and Model X facelifts. Change the rear shaft to permanent magnet, and the front shaft retains induction. Mixed configuration for forming permanent magnet inductors. This is also the second major blood exchange. Then why use induction instead? Because permanent magnet motors have a built-in flaw. It has magnets, and it will have a magnetic field, even if it does not give electricity. So there will be drag. That's back, EMF. At fast speeds, this kind of towing becomes noticeable. Instead of wasting energy, the induction motor does not have this problem at all. Without electricity, it's like an idling aluminum cage. It won't tow a truck, so the front axle induction motor is responsible for making up for it when needed. Output when needed, no power consumption at all when not needed. The rear axle permanent magnet motor is responsible for efficiency and main output. This ratio saves power more than permanent magnets plus permanent magnets. The fourth paragraph is from 2021. Let three motors appear. True permanent magnets in the back. A sensor is in front. The concept is exactly the same. The permanent magnet workhorse. Maximize induction assist efficiency. So when you look at the timeline, you will find one thing. Tesla is not abandoning any technology. We are going to put each motor back where it fits best. Permanent magnets are not here to replace induction. It's about the two technologies working together to achieve maximum efficiency and performance. Then we will talk about why permanent magnets become the main force. There are really three reasons. First, efficiency. The magnetic field of a permanent magnet motor is generated without electricity, so a lot of resistance loss is saved. You can save 10 to 20% on medium and high-speed cruising. Second, high-speed performance is good. IPM, permanent magnet, can be used for magnetic weakening control. High-speed performance is stronger than traditional permanent magnets. Heat is also easier to control. Third, the battery life is directly improved. Efficient cars, same size battery, can run farther than. This is why the Model 3 and Model Y perform so well. Where is the induction motor so strong? Its greatest strength is not efficiency, but non-towing. It rotates completely freely without electricity. Gold feature for the WD front axles. If you need to work, give it electricity, and if you need to save electricity, let it rest. Permanent magnets can't do that. So now you should understand the logic of Tesla. In the early days, I survived by senses. Mass sales, relying on permanent magnet heat efficiency. High efficiency or WD relies on permanent magnet and induction. Performance flagship. relying on double permanent magnets and one induction. It's not elimination, it's division of labor. It's not a slap in the face, it's maturity. It's not about changing it around, but changing to the most suitable position every time. Final conclusion sentence. Tesla's motor strategy has only one flaw. It's to put the permanent magnet in the main force. Put sensing on assists. Maximize efficiency. Induction has not been eliminated. It's just put back in the position that's best for it to play. That's all for today's explanation. Hopefully, you now fully understand the evolution of the Tesla motor. Stop being confused by contradictory claims on the internet.